Today we're going to be looking at the last lesson from Unit 7, Polygons, and it's about composite figures. You're going to be asked to find perimeter and area from some of your composite figures today. So make sure you're thinking about the difference between perimeter and area, perimeter being your distance around the outside, and area being the amount of surface that is covered inside of your shape. So composite figure is another word for a compound figure, and we did a little bit of that yesterday at the end of the area notes where we divided our figure up into some pieces. But a composite or a compound figure really has to be divided into basic shapes. So your rectangle, your parallelogram, your triangle, and circles, but we're not actually going to talk about circles in Math 1. We'll wait till we get to Math 2 to talk about those. So when you're looking at these shapes, you're trying to divide your shape into rectangles, triangles, and maybe even parallelograms, but really mostly rectangles and triangles. So those are the two formulas you're going to really need to work with on a regular basis. So when you are trying to find the area of a composite figure, you have two options. One of them is to do like we did yesterday. Divide the figure into shapes that you know and add those areas together. The one we're going to talk about or focus on a little bit more today is number 2, to find the area of the whole figure, assuming it was all there, and then subtract out the area of any portion that's not actually a part of the figure. This is very commonly used when you're trying to find the area of a shaded region, which is a very frequent test question, not like my test, but standardized tests, the ACT, the SAT, the PSAT, those types of things are where you're going to see a lot of shaded region questions. So the first one I'm going to do like we did yesterday. In fact, there was a question very similar to this yesterday where we asked to find the area. So this might be a good one to do your finding the area and adding the pieces together. So again, you have two things to think about. We're going to divide this one into a rectangle and a triangle. Remember, you're going for basic shapes, and you're going to start finding your areas. So let's look at the rectangle. Rectangles are length times width. So the length of this one would be 16, and our width would be 8. So 16 times 8, which is 128 square units. Now the triangle. The triangle is 1/2 base times height. So some of you are already looking over there and going, where'd she get that 14? Well, this right here, you'd have to turn your figure. This would be your base, where the red line is. So we would have to add 3, then this distance of 8, and then another 3. So 3 plus 8 is 11, plus this other 3 gives me 14. So this base along the red line is 14. Then the height of the triangle is the 16 that's marked down here. But this would be our height of 16. So 14 times 16, and then we need half of that. That would be 112 square units. Then we're going to add those two together, and we get 240 square units total for our composite figure. Now, another option that you have, instead of dividing it into multiple common lengths or rectangles and things, you can subtract instead. And that's what I want to show you on this example. So let's assume that we had this 14 meters and 12 meters here, and then this just went straight across, that all of it was there, that we didn't have this little cup cut out of the bottom right here. So let's just say, hey, straight across, that goes all the way at 14. So if I'm thinking about this as the second option where I'm going to subtract, I'm going to assume I have that whole big rectangle. So that whole big rectangle would be 14 by 12, which is 168 square meters. But the reality is I don't have the whole big rectangle. This part right here has been cut out. That's what causes this to dip down and come back up. So we have this right here that's not actually a part of the big rectangle. I'm going to call that the small rectangle. That small rectangle is 6 by 9. So I can do 6 times 9 and get 54 square meters. So if that whole thing was there, it'd be 168. But we need to take this 54 square meters out where our figure dips down. So we'll subtract, and we get 114 square meters as the area of the actual U shape there. More often, you're going to see option 2 used with the shaded areas. So here we have two rectangles. The large one is 10 meters by 12 meters. So the area there will be 10 times 12, which is 120 square meters. However, there is a white rectangle in the middle that is not shaded. So we need to look at that little rectangle. It is 7 meters by 2 meters. So 7 times 2 is 14 square meters. And so we'll need to take the big rectangle and subtract out the small rectangle that's not shaded in order to find the area of our shaded region, which after the subtraction turns to be 106 meters squared. Here's one that's a little bit trickier. We have a rectangle with a triangle cut out of it. In other words, this part right here, this white triangle, is not shaded, so we can't include that. Well, let's start with the big shape. The big shape is a rectangle, and so it would be length times width. 16 meters times 18 meters, that's 288 meters squared. Now that triangle is what has to come out of that. So a triangle is 1/2 base times height. Well, I know the height right here is 16, but I have a problem. I don't know this base right here. I know the whole thing is 18. I don't know this part or this part to be able to subtract to figure out what this is. I'm going to do a little side work. That's why I did this in red over here. So let's do a little side work. What kind of triangle is this? Right, it's a right triangle because it has a 90-degree angle in it. I know the hypotenuse has a length of 20, and I know this side right here, this leg, would have a length of 16. Well, I can find the missing side of a right triangle by doing the Pythagorean theorem. So a little side work of the Pythagorean theorem. We would have a leg squared plus a leg squared equals the hypotenuse squared. So 16 squared plus b squared equals 20 squared. 16 squared is 256. Leave the b squared. 20 squared is 400. Subtract the 256 on each side. B squared is 144. So we'll need to take the square root of both sides. Squares and square roots cancel out, so we just have b. And the square root of 144 is 12. So this base right here along the bottom of the triangle is 12 meters. Now we'll plug that into our formula. You'll notice I kept it in red. That's our 12 meters. That is the base. So 16 times 12, and then half of that. After we do our subtraction, then we will have 192 meters squared as the area of the shaded region. One more. Here our large shape is a triangle, so we're going to start with the triangle. The base of the triangle will be 14. 6 plus 2 plus 6, that whole length. The height of the triangle will be the height of this square, which is 2, plus the additional 3 centimeters. So that's a 5 centimeter distance. So 14 times 5 is 70, and then half of that is 35. Now we need the square. Remember, that's base times height, or length times width, or side squared. Doesn't matter which way you think of it. 2 times 2 is still going to give you 4 centimeters squared. So we take the big triangle, subtract out the small shaded square, and we have 31 square centimeters as the area of the blue shaded region. So when you are finding the area of composite figures, 3 things I want you to remember. Decide for yourself if it would be easier to add the parts or subtract the cutoff or unshaded area. Be sure to use the basic shapes. Don't try and get anything fancy. And don't forget to label your final answer with your units squared, whether it be inches squared, centimeters squared, units squared, whatever you might need. Make sure that you give that unit label on your final answer. As always, contact me if you have any questions at all.